Okay, when you're solving a word problem, if you use these 5 steps, it'll get you through every problem. Okay, the first step is the right side of the heading. The second step is the left side of the heading. I'll explain what that means in a moment. The third step is the equation. The fourth step is the solving the equation, so the solution to the equation. And the fifth point is the check. All right, so the first part of the right side of the heading is defining the variables. As we read this, it says, what are their wins, loss records? In other words, what we need to find out is the number of wins and the number of losses. So I'll start there. The number of wins and the number of losses. And we're just describing the knowns and unknown values in the problem. Step 2 is the left-hand side of the equation. So now we're going to assign values to this. It says they won 30 more games than they lost. Well, we don't know the number that they lost, but we know that they won 30 more than that. Now the equation. It says they played a total of 162 games. So if in baseball, you can't tie. So if you take the number of wins and you add the number of losses, you're going to get to 162. So that's the equation. Now step 4 is to solve this equation. So we have 2x is equal to, I'll bring the 30 to the other side, 132. I'll divide by 2, so x will be equal to 66. That's only part of the solution. We need to answer everything in the heading. So we need x plus 30. Well, 30 plus 66 is 96. Now we got to answer the question. I should have put 6 steps. Sorry. I lied when I said 5 steps. Now let's answer the question. And then we'll check the problem. Okay, so the answer is, see, this is just a solution. X is not a part of this. So now we have to put this into words. They won 96 games and lost 66 games. Now to check, you add these up. There's 2 checks. One is, do these really add up to 162 games? Well, you can easily check that. And the other check is, did they really win 30 more than they lost? You can check that as well. Let me write this a little cleaner. Okay, so there you have it. All right, number 3. Steps 1 and 2, if you can draw this and not write it out, it can be a lot easier. So when we look at this, it said that they found the length was 42 feet longer than it was wide. So we don't know this side, that's x, but this is 42 feet longer. Now, that's the equation, or the left and right hand side. The equation is that we take the 2 sides and add them up. That only counts for half of the perimeter, so we can multiply all of this by 2 to account for this side and this side. And this is all going to add up to 228 feet. So we have 2 times 2x plus 42, or 4x plus 84 is equal to 228. I bring my 84 over, and 4x is equal to, let's see, 16 less than 328 is 322, 312. And x is going to be, well, 4 goes into 31 7 times with 3 left over, so x equals 78. That's only part of the solution, or the solution. I also need x plus 42. And that's going to be 42 plus that is 80 plus 40 is 120. So now we need to answer the question. The width is 78 feet. That one little hyphen there is a foot. The length is 120 feet. So there's the answer. And then you can check it pretty easily by seeing if we adding 42 to the width gives us the length, and if we add up those two sides and multiply by 2, if we get 228. Then we're not going to though. Let's see what I did wrong. Okay, so we're going to apply the 6 steps here. If you can draw the heading rather than writing it out, that's just as acceptable and it's a lot easier. So the width is, we don't know, but the length is 42 feet longer than that. So that's steps 1 and 2. The equation is if we take a single length and a single width, we add it together, that's half the perimeter. So if you multiply this by 2, you'll get the entire perimeter, which is 228. So 2 times 2x plus 42, that's 4x plus 84 equals 228. Now if I subtract 84 from each side, I get, 16 less than 128 is 112. Wait a minute. 228 minus 84 is 144. And then if I divide by 4, I get x is equal to 36. That's only half of the solution. I also need x plus 42, and that's equal to 78. So now the answer. The width is 36 feet. The length is 78 feet. So I'll circle that as the answer. Now to check it, I have 2 checks. One is the length really 42 more than the width? And it's pretty obvious that it is. And the second thing, is the perimeter correct? Well, if I add those 2 things up and multiply by 2, adding them up, I get 114. So that's half the perimeter. So if I double that, I do get 228. So that is the correct answer. All right, number 5. We're going to start with the right-hand side of the heading. So we're looking for the values that we're trying to find, the knowns or the unknowns. And that's going to be the questions asking, what's the revenue for each company? So Walmart's revenue and Exxon's revenue. So those are the 2 things that we're looking for. Now step 2 is the left-hand side. Well, it says that Exxon revenues was 24 billion more than that of Walmart. We don't know Walmart, so we say X, and Exxon then would be X plus 24, and we're in billions. The total was 656. So if we take these 2 and add them together, we're going to get the total. Now when I solve this, I get 2x is equal to, I bring the 24 over by subtracting, and I get 632. I divide by 2, and I get x is equal to 316. If I add 24, I get 340. So now the answer. Walmart's revenue was 316 billion. Exxon's revenue was 340 billion. Now, the last step is the check. Is 340 really 24 more than 316? It is. Do these really add up to 656? They do. So we know that's the answer. Okay, in this problem we're solving for x and y, and they're just angles, so I'm not even going to bother with the heading because those are the two angles we're looking for. So, okay, so here's the thing. This is a straight here. This is a straight angle. So y plus 3x plus 10 must be equal to 180. And the next equation is x plus y plus 90 are the three angles, and all three angles in every triangle also add up to 180. So I'm going to simplify each of these. Now when I simplify this top one, I'll move the 10 over, so I have y plus 3x is equal to 170. And this one I'll write as y plus x is equal to, when I bring this over to this side, I get 90. Now I can add these two together. I'm going to multiply this one by -1, and I'll get negative y minus x equals negative 90. I'll leave this one the same. And I'll add these together. Y's go away, 3x plus that is 2x, 170 plus this is 80, so x is equal to 40. And then I can take that and plug it anywhere in, like over here, and say that y plus 40 equals 90, so y is equal to 50. So x is 40 degrees and y is 50 degrees. Number 11, let's figure out what we're being asked to find. We're being asked to find the number of each type of sandwich, and we're talking about Big Montana sandwiches, so let's start there. The right-hand side equals the number of, or not the number, the cost of a Big Montana and the cost of a junior roast beef. Okay, so why don't we call a Big Montana a B and a junior roast beef a J? Okay, now 15 junior roast beef and 10 Big Montana added up to a total of $75.25. So 15 times B plus 10 times, 15 times J a junior roast beef is J, plus 10 times the Big Montana, B, this is $75.25. That's one equation. The second equation is that 30 junior roast beef and 5 Big Montanas added up to $84.65. So 30 junior roast beef plus 5 Big Montanas was $84.65. Now, I can either bring my J's to 30 or my B's to 10. I'm going to decide to bring my B's to 10. So, if I multiply this one, I don't multiply this one by anything. But I multiply this one by -2, I'll get negative 60J minus 10B is equal to negative, where am I? Let me just use a calculator so I don't make a mistake. 84.65 times 2 is negative 169.30. And if I add these together, I get my third equation, which is negative 45J, the B's go away, equals negative 9405. If I divide by 45, I get 209. This tells me the cost of a junior roast beef. Now, if I take that and put it into one of my originals, like say this one, $15 times that plus 10B equals 7425. Well, 15 times 2.4009 is 3125 plus 10B equals 7425. So I subtract and I get 10B is equal to 4290. So B must be equal to 4.29. So now I found them both. So the answer is a junior roast beef costs $209 and a big Montana sandwich costs $429. And that's everything. Okay, part A. 60 ounces of solution at 10% is 6 ounces of pure acid. Part B, 60 ounces of liquid at 25% is 15 ounces of pure. Part C, 60 ounces of liquid at 40% pure is 24 ounces of pure. And part D, 60 ounces of liquid at 50% pure is 30 ounces of pure liquid or pure acid. If 1 pound of turkey costs $1.29, X pounds will cost X times that, or 1.29X. X gallons at 25% would be 0.25X of pure. Y gallons at 35% would be 0.35Y. And 20, this is 0.32, so this would be 20 times 0.32, which would be 6.4 acid of gallons of pure alcohol. Let's make a little table. So we'll say the number of liters times the percent purity is equal to the number of pure liters. And we have two different things plus a mixture. So we have a 20% solution. Let's call that a 10 first. We have a 10% solution, a 20% solution, and a mixture. Okay, so this stuff is the easy stuff. So I'll put this in 0.1, 0.2, and, well, I'm sorry, the mixture should be 20%. I misread this. The mixture should be 20%. And this is pure acid. So that's 100% or 1. Okay. Pure acid is added to this 10% solution to obtain 54 liters. So let's start filling this stuff in. We only know that this is 54. We don't know how much of either of the other items there are, but we do know it adds up to 34. So let's choose X for one of them and the total minus X for the other one. And that way, no matter what X is, it's always going to add up to our total mixture of 54. So now I'll multiply across and get 0.1X. This is 1 times that, which is still 54 minus X. And 0.2 times this is 108, 10.8. Okay. These two boxes will add up to our mixture. So I have 0.1X plus 54 minus X is equal to 10.8. 0.1 minus 1 is a negative 0.9. And I'll bring my 54 to the right by subtracting it. 10.8 minus 54, well, 11 minus 54 is negative 43. So negative 43.2. I better use a calculator and double check that. 10.8 minus 54 is negative 43.2. Divide by negative 0.9. And I got X is equal to 48. Now, what does that tell me? That tells me that there is 10 liters of the 10%. But we also need the 54 minus X. So 54 minus X is 54 minus 48, which is 6. So the answer would be 48 liters of 10% acid mixed with 6 liters of pure acid. Okay, party mix, if it's 250 per kilogram times X kilogram, this must have those two things multiplied together, so 2.5X. This will be 1Y. And this is X plus Y, because we're just mixing it together. So this must be 1.7 times X plus Y. Okay, so the mixture must be just adding those two things together, X plus Y. We multiply across and get 2.5X here. We multiply across and get 1Y here. And we multiply across and get 1.7 times X plus Y here. So the equation is the value of the nuts and the cereal add up to the value of the mixture. So 2.5X plus, Okay, in this problem it tells us that there's 30 kilograms of the mixture. So I know that this is 30. When I multiply across, I get 2.5X here. When I multiply across, I get 1 times Y is here. And when I multiply across, I get 30 times 1.7 is $51 here. So one equation is X plus Y is equal to 30. The other equation, when I add up these two, I get 2.5X plus Y is equal to 51. I'm going to solve this using substitution. So I'm going to solve this for Y. So Y is equal to 30 minus X. And I'm going to plug that in here. So 2.5X plus 30 minus X is equal to 51. This tells me, when I combine my X's, that 1.5X must be equal to, I'll bring this over by subtracting, 21. So I'll divide 21 divided by 1.5, and I'll get X is equal to 14. Since Y is equal to 30 minus X, which is 16. So we have X stands for the number of kilograms of nuts. So 14 kilograms of nuts and 16 kilograms of cereal. Okay, we're going to set up two equations. One is the total principal is 3,000. So X plus Y is equal to 3,000. And the other is the total interest is equal to 100. So 0.02x plus 0.04y is equal to 100. Now I'm going to solve this using substitution. So I'll solve this for either one of the variables. X equals 300 minus y, and I'll plug that in here. So 0.02x, which we now know is 300 minus y, plus 0.04y is equal to 100. So 2 times 3 is 6, minus 0.02y is equal to, plus 0.04y is equal to 100. So I've got, let's bring this up here. We've got negative 0.02 plus 0.04 is 0.02y is equal to 94. That's subtracting 6 from each side. So y is equal to, I'm going to divide each side by 0.02, and I get 4,700. Now we're going to plug this in over here to find x. X is equal to, wait a minute, oops, I made a mistake here. This is 3,000, not 300. So this is 3,000. This is 3,000, so this is going to be 60. And when we subtract, I'm sorry about all this, but 100 minus 60 will be 40. And 40 divided by 0.02 is 2,000. Okay, so now we have x is equal to 3,000 minus 2,000, which is 1,000. So x is the principal invested at 2%, and y is the principal invested at 4%. So our answer, we can write down $2,000 invested at 4% and 1,000 invested at 2%. When you check this, there's a total of 3,000 invested altogether. That's just the sum of these two amounts. And then if you multiply 2,000 by 0.04 and get the amount of interest made there, and you multiply 1,000 by 0.02 and get the amount of interest made there, and you add those amounts up, you should get $100. 2,000 times 0.04 is $80 in interest. 1,000 at 2% is $20. So this adds up your total $100 in interest, which is what you know you should have. All right, number 25. The speed of the boat in still water is 10 miles per hour, and the current is X miles per hour. So when you're going upstream against the current, you should be going at 10 minus X. For part B, when you're going downstream, you should take the current and add the speed of the boat and add the current, so it'd be 10 plus X. Okay, so it says that the fishing spot is 36 miles away, and so the round trip is also going to be 36 miles. But he says that the round trip only takes 1.5 hours. Well, we have two equations here. The rate times time, so we have 2 times x minus y is equal to 36. That's this equation. And this equation will be 1.5 times x plus y. Now, instead of distributing, If you divide each side by 2, you'll find that it's a lot easier here, so that you get x minus y when you divide the left by 2 equals 18 when you divide the right by 2. And on this equation, if we divide by 1.5, we're going to get x plus y on the left, and on the right, 36 divided by 1.5, I'll just use a calculator so I don't make a mistake, and that's 24. Now we can see that we have equal but opposite y's, so we can just add these together and eliminate the y's. So we'll get 2x is equal to 42, so x is equal to 21. That tells us the speed of the boat in still water. Now if we want to find y, we say 21 minus y is equal to 18, so negative y is equal to negative 3, so y is equal to 3. And that tells us the speed of the current. So we'll say the boat goes 21 miles per hour in still water, and the current is 3 miles per hour. And there's the solution. Okay, step 1 is the right-hand side of the heading, and we look, the question is asking how many of each type of ticket is sold. And there are general admission tickets and there's student ID tickets. So let's start there. Equals number of general admission tickets and the number of student tickets. Okay. So I'll say general is G and student, I'll put student as T. I don't like putting an S because I might mistake it for a 5 at some point. Well, general admission were $5 and student were $4. So first of all, G plus T, the total number of tickets, was 184. That's given right here. The second equation is that if each general admission ticket cost $5, then the amount of money spent on them was 5G. And each student ticket was $4, then the amount of money spent on those was 4T. If we add those up, we'll get the total amount of money spent altogether, which is 812. So I'm going to solve this using substitution. I'll solve this one for either variable, like G. So G is equal to 184 minus T. And I'll plug that in here. So I have 5 times 184 minus T, that's my G, plus 4T is equal to 812. That's just rewriting this and substituting that in. So now, I'll bring this up here. 5 times 184, let me grab a calculator, is 920 minus 5T plus 4T is equal to 812. So negative, I'll combine my like terms, that's negative T is equal to 812 minus 920. I get negative 108. So T is equal to 108. That means that there was 108 student tickets sold. And let's now solve for G. G is 184 minus T, which is 108. So this is 76. So our final answer is 108 student tickets and 76 general admission tickets. Okay, so our right side of the heading, it looks like we have, how many different things? We have citrons, fragrant wood apples, call it apples, and actually that's it. Okay, so I'm going to say equals number of apple or number of citrons and equals, oh, not number, price of. We're looking for the price of each one. And equals the price of a wood apple. Okay, so I'll say that this is C and this is A. Those are my variables. And here we have 9 of these citrons plus 7 of the apples is 107. So that's one equation. 9C plus 7A equals 107. And then a little later, it says that 7 citrons and 9 apples is 101. So 7 citrons and 9 apples is 101. So I'm going to use elimination to get rid of these. So let's get rid of the C's. Okay, so I'm going to multiply this by 7 to get to 63. And I'm going to multiply this by negative 9 to get to negative 63. So when I multiply the top one by 7, I get 63C plus 49A is equal to 7 times 107 is 749. When I multiply this, I get negative 63C minus 81A is equal to negative 909. And I add these together, and it looks like I get negative 32A is equal to negative 160. That tells us that A is equal to 5. Okay. Now I'm going to take that and plug this back into one of my originals. So let's say I plugged it into this one here. I'll have 9C plus 7A, which we now know is 5, is equal to 107. So 9C plus 35 equals 107. So 9C is equal to 72. So C is equal to 8. So our answer is a citron. Let's put this in green. A citron is $8. A wooden apple is $5. Okay, number 37, they give us these two equations, this and this. So we have z equals x plus 10. We have x plus y equals 100. And the final equation is always the fact that all three angles in any triangle is equal to 180. Okay, so let's see. This is missing a y, this is missing a z, and the other one, let's see if we can use substitution. Yeah, I believe we can. Okay, so let's look at this. I'm going to substitute x plus y with 100. So this becomes 100. And now I have plus z equals 180. So z must be equal to 80. And this tells me that z is equal to x plus 10. So 80 equals x plus 10. So 70 must be equal to x. So we've got that. And finally, this equation here tells us that x plus y is 30. So we've got 70 plus, I don't know what I just said, but 70 plus y is equal to 100. So y must be equal to 30. All right, so the angles are angle x equals 70 degrees. Angle y is equal to 30 degrees. And angle z is equal to 80 degrees. All right, let's set up a heading. So we want 3 sides. So I have the shortest side, the middle side, and the longest side. So that's the right-hand side. Now, the longest side is 4 centimeters less than the sum of the other 2 sides. Well, let's fill that in a second. Twice the shortest side, so we'll call that x, twice that is 9 centimeters less than the longest side. So this must be 2x minus 9. Let me make sure that makes sense. Twice the shortest side is 9 centimeters less than the longest side. Actually, that means I need to put a plus here, because if the shortest side is x and we doubled that, that 2x would still be 9 centimeters shorter than the longest side. Okay, so I'm going to find 3 sides. I'll say that we have the equals the shortest side, the middle side, and the longest side. Okay, I'm going to call this H because I don't want to use S. It looks like a 5. This will be M, and this will be L. All right. Now, the perimeter of the triangle is 70. So I'm going to say H plus M plus L is 70. That's one equation. Now, the longest side is 4 centimeters less than the sum of the other 2 sides. So the other 2 sides are H plus M, but this is 4 centimeters less, so minus 4. And finally, twice the shortest side is 9 centimeters less than the longest side. Okay. All right, so these are my three equations. All right, so this bottom one does not have an m. So if I can eliminate m using these other two, then I'll have two equations with only two variables. So let's do this. I'm going to move all my variables to the left, and I'll put them in the same order as the top one. So I have negative h minus m plus L is equal to negative 4. That's just moving my variables to the left. And I'll just write this one down again. H plus M plus L equals 70. And I add these up, and I got rid of two variables. So I have 2L is equal to 66. So L must be equal to 33. Well, now I can use this equation here to find H. So 2H is equal to L, which is 33, minus 9. So 2H is equal to 24. So H must be equal to 12. And finally, I can use this last equation here to find my last variable. So I have H and I have L, and now I need M. Okay. H plus M plus L equals 70. So 12 plus M plus 33 equals 70. M, combining like terms, M plus 45 equals 70. So M must be equal to 70 minus 45, which is 25. So I'm just going to list these sides. The sides are, let's go from shortest to smallest. So 12 cm, 25 cm, and 33 cm. And it's obvious, you don't have to label like the shortest, middle, and longest. It's obvious what they are once you list them. Okay, let's start with the right-hand side of the heading. We have independents, Republicans, and Democrats. So let's start there. Equals number of independents Republicans and Democrats. So let's call this R, D, and I. Okay. I know that there's 100 total voters. So that's one equation. I plus R plus D equals 100. Let's see. It says 10 more Americans identify themselves as independents than Republicans. So that means that in order to make them equal, we'd have to add to the smaller amount. So we'd add 10 to Republicans. So I is equal to R plus 10. And finally, 6 fewer, let's do that in blue. 6 fewer Americans identify themselves as Republicans than Democrats. So in other words, there are 6 fewer Republicans than Democrats. So in order to make them equal, I'd have to subtract 6 from the Democrats, not from the Republicans. So R is equal to D minus 6. Okay, so those are my three variables. Okay. So this one here is missing a D. This one here is missing an I. And that one's got all three of them. Okay, so why don't I eliminate one of the variables? I guess I'll eliminate R. Okay, so let's bring this up here. And I'll say that negative R plus I is equal to 10. And I'll bring this one over here. And I'll bring my D to the left. So I have R minus D is equal to negative 6. Now if I add these together, I'll get I minus D is equal to 4. Okay. And let me pause. Okay, in this problem, we have three different types of voters. We have independents, Republicans, and Democrats. All right. So I made the right-hand side of my heading. Now I'm going to make the left-hand side of my heading. I'm just going to create variables to represent those things. So I'll call I the independents, R the Republicans, and D the Democrats. I know that there are 100 voters. So if I add these all up, I plus R plus D, I'll get 100. Now let's look at the relationships between some of these. Okay, so it says 10 more Americans identify themselves as independents than Republicans. So in other words, there's 10 more independents than Republicans. So we'd have to set them equal, we'd have to add 10 to the Republicans. Let me write that a little nicer. R plus 10. Because there's 10 more independents. So if we want to set an equality, we have to add the 10 to the smaller amount. Now this next part here says there's 6 fewer Americans that identify themselves as Republicans than Democrats. So if we want to set them equal, we're going to have to subtract 6 from the Democrats to make them equal to the Republicans. So Republicans is equal to Democrats minus 6 because there's 6 fewer Republicans. All right. Now, let's use substitution. I can substitute, well, let's solve this. In other words, I is in terms of R. Let's make D in terms of R. So this will tell me that D is equal to R plus 6. Now let's take this equation and say that since we know that I plus R plus D equals 100, and we know that I is equal to R plus 10, then we add this R, and now we add the D, which is R plus 6, we get 100. Now we have a single variable. So we combine like terms and we get 3R plus 16 is equal to 100. So 3R is equal to 84. So R is equal to 28. Now that we found R, we can use this to find I. I is equal to R plus 10, which is equal to 28 plus 10, or 38. And finally, we'll find D here. D is equal to R plus 6, which is 28 plus 6, or 34. So finally, let's put our answer down. We have, where am I? 28 Republicans, 38 Independents, and 34 Democrats. Okay, in order to check this, first let's see if we have 100 voters. When we add up those three numbers, 60, 80, 96, we do get 100. And then, are there really, let's check the facts, are there really 6 fewer Republicans than Democrats? Well, 28 is 6 fewer than 34 Democrats, so that's true. And finally, it says, are there really 10 more independents than Republicans? Well, 10 more independents than Republicans. 38 is 10 more than 28. So all of the facts check out, so that is our answer. Page 319. Okay, number 20, let's draw our heading. So the length is 30 feet longer than twice the width. So we call the width X, but this is 30 feet longer than twice the width. Okay. The perimeter is 570. So if we take 2 of the sides and add them up, that's going to be half the perimeter. So if we multiply this by 2, we'll get the entire perimeter, which is 570. So this becomes 3x plus 30, excuse me. Times 2. This will be 6x plus 60 is equal to 570. So 6x is equal to 510. So x must be equal to, well, 6 goes into 51. Let's see, 8 times with 3 left over, so 85 times. And bringing this up here, 2x plus 30 is 2 times 85, 170, plus 30 is 200. So this is an 85 feet by 200 foot ring. All right, when you read through this problem, ultimately what they're asking you to find is the price for a Red Sox ticket and for a Cubs ticket. So let's make our heading. The right-hand side is equals the price of a Red Sox ticket and the price of a Cubs ticket. We'll call this R and we'll call this C. Okay. Now, our equations. It says that 4 Red Sox tickets, so 4R plus 4 Cubs tickets cost this. Then we read on, it says 2 Red Sox tickets and 6 Cubs tickets is $252. Okay, I'm going to use elimination, so I'm going to multiply this equation by -2 so that I can get rid of my r's, and I get -4r minus 12c is equal to, well, let's use a calculator, 252.24 times 2 is a negative 504.48. And I'll leave this one alone. When I add these together, I get negative 8c is equal to negative 227.60. So let's bring this up here. That tells me that c is equal to, when I divide by 8, or negative 8, I get 28.45. Then I can take that in either of my original equations, like say this one. I'll bring that up here. And I'll say 4r plus 4c equals 276.88. And my c is 28.45. So 4r plus I multiply that and get 113.80 equals 276.88. So 4r equals 163.08. I divide by 4 and I get r is equal to 40.77. So Cubs tickets cost $28.45 and Sox tickets cost $40.77. That's $40.77. And that's it. Okay, when you're with the wind, you add the plane and the wind together, and against the wind, you have to take the speed of the plane and subtract the speed of the wind. Distance is rate times time, so this is going to be 1.75 times your x plus y, and this is going to be 2 times your x minus y. Okay. Now, my one equation is, and by the way, this is 560 miles in 1.75 hours. So 1.75 times x plus y must be 560. And then the other equation is 2 times x minus y is a round trip, so it's going to be the same 560. Okay, instead of distributing, I'm going to take this equation and divide by 2. Oh, excuse me, not by 2, but by 1.75. So I'll get x plus y. I'll do that in red. X plus y is equal to 560 divided by 1.75, and I get 320. This equation I'm going to divide by 2 to get rid of that 2, and I end up with x minus y is equal to 560 divided by 2, which is 280. Now I can add these together and get rid of the y's. X and x add up to 2x, 280 and 320 add up to 600. So x must be 300. Then I can take either one of these equations to find the speed of the wind. So 300 plus y is equal to 320. So y must be equal to 20. So that's the speed of the wind. So we can say the plane goes 300 miles per hour. The wind is 20 miles per hour. Page 319, numbers 21 or 20 through 22. Okay, number 13. Here we have they're both going for 3.5 hours, and one car travels 30 miles slower than the other. So why don't I say equals speed of fast car and speed of the slow car. We'll call this one X. The other is 30 miles per hour slower, so X minus 30. Now, if they're both traveling for 3.5 hours, the distance that the first one goes is 3.5 times that. So 3.5x, that's the distance the fast car went, plus 3.5x minus 30, that's the distance the slow car went, and we add that up and we get 420 miles. So this is 3.5x plus 3.5x minus 90. Well, I think that's 105, but I'm going to double check. 3.5 times 30 is 105. Goes 420. I add this, the x's up, and I get 7x equals, I add 105 to each side, and I get 525. And I take 525 and I divide by 7, and I get x is equal to 75. That tells me the speed of the fast car. Now I go x minus 30 equals 45. That's the speed of the slow car. So the fast car went 75 miles per hour. The slow car went 45 miles per hour. Okay, let's set up a table for this. We have the number of liters times the percent purity is equal to the number of pure liters. And hopefully that sentence makes sense. And once you set that up, it's just a matter of filling in the table. Okay, we have two things that we're mixing together to get to a mixture. I'll put a double line here so that I understand the bottom line is my mixture. I'll put a line under the multiplication, a line under the equals to separate my boxes. I have a 40% solution, a 20. Oh no, I'm sorry, the 40 is the mixture. So this is a 40% solution, a 20% solution, and a 50% solution. A little double checking. This mixture has to be mathematically in between these two values. If your mixture is outside of those two values, it's impossible. You cannot take two things together, mix them together, and get something that is outside of their range. All right, so that's just a double check there. All right, this we'll put in the easy stuff. That's 0.4, this is 0.5, this is 0.2. The chemist needs 12 liters of this stuff, so I'll put in 12 there. we don't know how many liters of this, but if they're going to add up to 12, instead of using y, I'm just going to say that this is 12 minus x. That's a little trick where if you have two items and you don't know how much of each item there is, but you do know what it adds up to, choose a variable for one of them and the total minus a variable for the other. And that way you can always work in one variable. Now when I multiply across, I get 0.2x here. I get 0.5 times 12 minus x here. And I get the product of these two things here. Okay, so my equation is going to be 0.2x plus 0.5 times 12 minus x is equal to 12 times 0.4. So let's do a little math here. We have 0.2x plus, I'm going to distribute this 0.5, and I'll get 6 minus 0.5x is equal to 12 times 0.4. I think that's 4.8, but I'm just going to double check. Yep. That's 4.8. Now I'll combine my like terms. 0.2 minus 0.5 is negative 0.3x. 4.8 minus 6 is a negative 1.2. So x must be equal to 4. Then I need to find this value here, the 12 minus x. So let's bring that up over here. 12 minus 4 is 8. So I know that I have, there are, let's see, 8. Let me write that a little nicer. 8 liters of the 50% alcohol solution. And I have 4 liters of the 20% alcohol solution. All right, number 15, we're looking for the price of an AC adapter and a rechargeable flashlight. Okay, so let's start there. Equals price of an AC adapter and the price of a flashlight. Okay, so I'll call this one A for AC adapter and this one F. Now, let's look at the equations. 7 AC adapters must cost 7A. So I'll take 7A and I'll add that to 2 flashlights, so 2F. That's going to be $86. That's there. Okay, now let's look at the next sentence. 3 AC adapters, so that's going to cost 3A. And 4 flashlights, that's going to cost 4F. That will add up to a total of $84. Okay, so I can either get rid of my A's by bringing them up to 21 or the F's by bringing them up to 4. I think it's a lot easier to bring those to 4, so that's what I'm going to do. I'm going to multiply this by negative 2. And I'll get negative, let's put that in blue. I'll get negative 14A minus 4F is equal to negative 172. And this I'll leave alone. So 3A plus 4F is equal to 84. And I'll add these together and I'll get negative 11A, the F's go away, and negative 172 plus 84 is negative 88. So a must be equal to positive 8. Then if I take that and I plug it into either one of these, like this one here, 3a must be 24 plus 4f equals 84. That means that 4f is equal to 60 when I subtract. And now I'll divide by 4, and f is equal to 15. So my final answer, I'll bring these up over here. Flashlights cost $15 each, and AC adapters cost $8 each. And that's that. Page 339. Number 1, AB squared. Is this equal to AB squared? Well, we got to distribute this exponent, so we would get A squared B squared. This is not equal to AB squared, so this is no, not correct. Number 2, is quantity 5x cubed equal to 5 cubed x cubed? Well, when we distribute this in, we do in fact get that. So yes, this is correct. Number 3, when we bring our exponent in, we bring it into the numerator or the denominator. So is this equal? Well, 4 cubed over a cubed is not equal to 4 cubed over a, so this is not correct. Number 4, is this good? Well, when the bases are the same, we add the exponents. So this is y to the 8th, and that's not equal to y to the 12th, so this is not correct. Number 5, is this product correct? Well, when the bases are the same, we add the exponents. So this would be x to the 7th, which is equal to that, so this is correct. Okay, anything to the 0 power is equal to 1 besides 0, and it's saying that y is not equal to 0. So this is x times 1. Is that equal to 0? No. X, this should be equal to x, so this is not true. Okay, remember, we're not going to multiply these 13s together because these are bases. And when the bases are the same and we're multiplying, it stays the same, but we simply add the exponents. So this becomes 13 to the 12th power. I'm not going to evaluate that any further. We'll just leave it in exponential form. Okay, and again, the bases are the same, so the base remains the same, and we simply add the exponents. So this is 9 to the 10th power, and we can leave it like that. Okay, the bases are the same, so we keep the base and we add the exponents. This is a 1 here, even though it's not written. So this becomes 8 to the 10th power. Okay, the bases are the same, so we simply add the exponents when we're multiplying, and we get 12 to the 7th power. So here we're multiplying and the bases are all the same, so the base remains the same, and we simply add the exponents, and so we get x to the 17th power. Okay, we're going to these are not bases, these are coefficients. They don't have an exponent on them. So we do multiply those together and we get negative 27, but the bases are the same, so they remain w, and we just add the exponents there. Okay, here we're going to multiply our coefficients together, and we get 2 times 9 is 18, and we have x to the 2 plus 1, which is 3, and y to the 5 plus 3, which is 8. And we're all done. Okay, here we have a base of r and a base of s. They're not the same, and there's nothing we can do to simplify. The product rule does not apply here, so that's just a simplified answer. Okay, part A. Anything to the 0 power is 1, so that's 1. Part B, we have 9 to the 0 power is 1, and then we apply the negative, so we end up with -1. Part C, anything to the 0 power is 1, so that is 1. And finally, part D, this part is 1, but then we tack on that negative, so we get -1. So this matches up to letter B, this matches up to letter C, this matches up again to letter B, and this matches up to letter C. Anything to the 0 power is 1, so the answer here is 1. Okay, here we have this portion is equal to 1, and then we tack on that negative, so our answer is -1. All right, number 25, anything to the 0 power is 1, so the answer here is 1. Okay, here we have a 1, and then we tack on the negative, so this will be a -1, minus this is a 1. -1 minus 1 is -2. Okay, part A, any negative exponent is inverted. So this is like saying 1 over 4 to the positive 2, which is 1 over 16. Part B, we do the same thing, but then we tack on the negative there. So this is going to become -1 over 16. This here is going to become, well, there's an even exponent, so that's going to make this a positive 16. So this will become, the negative exponent inverts it, so this becomes 1 over 16. And finally, part D, we do the same thing we did in part C, but then we tack the negative on. So this is -1 over 16. So this corresponds with letter B. This is letter D. And again, so this must be letter B, and this must be letter D. Okay, 5 to the -4th is the same thing as 1 over 5 to the 4th, which is 1 over 5 times 5 times 5 times 5, which is 625. Okay, 8 to the -1 is simply 1 over 8 to the 1 power, so that's just 1 over 8. Okay, here we're going to distribute that exponent, so we have 4 to the -2, x to the -2, which is going to be 1 over 4 to the 2, well, let's do it in 2 steps. Okay, we're going to distribute that negative, and we're going to get 4 to the -2, x to the -2, which is equal to 1 over 4 to the 2, x to the 2, and then we'll evaluate and get 1 over 16, x to the 2nd. Okay, in this problem, there is no parentheses, so that 4 is not affected by that exponent, so it remains up in the numerator. Let me do this in a different color. So the 4 remains up in the numerator, but the x to the 2nd becomes an x to the positive 2nd in the denominator. And then we can't simplify any further, so that's our answer. Okay, this is going to become -1 over a to the positive 3 power, and there's nothing else we can do to simplify. Okay, there's a couple things in here going on. One is that we have a parentheses with a negative inside of it and an even exponent. That even exponent is going to eliminate that negative from inside of the parentheses. So our first step that we have is this becomes a positive a to the -4, which is a 1 over a to the positive 4. One of the key things here is to understand that that negative got eliminated because of an even exponent. If that was an odd exponent, the negative would still be there in the answer. Okay, 5 to the -1 is 1 over 5. 6 to the negative 1 is 1 over 6. And now we need a common denominator, which is 30. So I had to multiply this one by 6. So we have 6 up there. I multiplied this one by 5. So I have 5 up there. And now I add these together. 6 plus 5 is 11 over 30. And that's the final answer. Okay, 8 to the negative 1 is 1 over 8. Minus, this is 1 over 3. We get a common denominator of 24. So this one I had to multiply by 3. So I get a 3 up there. This one I had to multiply by 8. So I get an 8 up there. And now that I have a common denominator, I subtract and I get negative 5 over 24. Okay, in order to make that negative exponent positive, I bring it to the other side of the fraction. So this is going to be 4 to the second power over 1, which is just 16. Okay, in order to make this exponent positive, I bring it to the other side of the fraction, in which case I get 2 to the second. I bring this up to the other side of the fraction to make that a positive exponent. So I get 3 to the third. 3 to the third is 3 times 3 times 3, which is 27. 2 to the second is 2 times 2, which is 4. And that's a simplified fraction. Okay, there's more than one way to do this, but one way is to distribute that exponent. So we get 2 to the negative 3 over 3 to the negative 3. And then I make the exponents positive by bringing them to the other side of the fraction. So I get 3 to the 3 over 2 to the 3. And 3 to the 3 is 27. 2 to the 3 is 8. And there's nothing I can do more to simplify. Okay, and again, I'm going to distribute this exponent. So I get 4 to the negative 2 and 5 to the negative 2. And then I'm going to bring these to the other side of the fractions to make the exponents positive. And I'll get 5 to the positive 2 and 4 to the positive 2. So I'll end up with 25 over 16. And there's nothing else I can do to simplify. Okay, to make this exponent positive, I simply invert it. So this becomes a positive 3 over 1. To make this exponent positive, I simply invert it. So this becomes negative 3 over 1. And notice that that negative doesn't go away because this is an odd exponent. Okay, so this next one, this negative is sitting out there. I invert the fraction in there to 3, and then I tack on that negative, so I end up with negative 3. And finally, I invert this fraction, and I get negative 3, but then I apply that negative, so I get positive 3. Okay, this corresponds to letter B. This corresponds to letter D. So this must also correspond to letter D, and this must correspond to letter B. Okay, when you're dividing and the bases are the same, the base remains the same, and then we subtract the exponents. So this is 4 to the second, which is 16. Okay, and again, we're dividing here. The bases are the same, so we're going to have x to the 12 minus 8. Remember, when you're dividing, the bases are the same. You simply subtract the exponents. So this is x to the 4. Okay, when we're dividing, we're subtracting the exponents, and there's more of them on the bottom, so they're going to end up on the bottom. We have 10 minus 7 here, which is going to be 1 over r cubed. Okay, in order to bring these up here, we invert the sign. So this is like saying 6 to the 4 times 6 to the positive 2, which is 6 to the 4 plus 2, which is 6 to the 6th power. And I'm going to leave that in exponential form rather than trying to evaluate what 6 times 6, 6 times is. Okay, I'm going to bring this 6 to the 3 down, so I'm going to end up with 1 over 6 to the 7th times 6 to the 3, or in other words, 1 over 6 to the 7th plus 3, which is 1 over 6 to the 10th. And again, I'm going to leave that in exponential form rather than trying to determine what that value is. Okay, again, I'll bring this up to the top, so I'm going to end up with 7 times 7 to the 1, which is 49. Okay, here x and y are different bases, so there's nothing we can do. The quotient rule does not apply, so this is the simplified answer. Okay, when you're bringing an exponent up to yet another exponent, the rule is that we multiply the exponents. The easy way to remember that is anything to the 6th power means it's times itself 6 times. And then you can clearly see that we could use the product rule here. 1, 2, 3, 4, 5, 6. So this is x to the same base, 3 plus 3 plus 3 plus 3 plus 3 plus 3, which is x to the 18th. You don't have to do all of that. We can just multiply those exponents together. Okay, so we're going to distribute that exponent, and we'll get 3 to the 3rd power over 5 to the 3rd power, which is 27 over 125. Okay, we're going to distribute that exponent, and we'll get 4 to the 3rd power, t to the 3rd power, and then we'll evaluate 4 to the 3rd power. 4 times 4 times 4 is 64, t to the 3rd power. Okay, first of all, this is an odd exponent, so it will not eliminate that negative. So we're going to end up with that negative, and we'll have 6 to the 3rd power, x to the 2 times 3, which is the 6th power. And now we'll evaluate that negative 6 to the 3rd power. That's 6 to the 3rd power is 216. And we have x to the 6th power. And that's all we can do. Okay, on this problem, this is an odd exponent, so it will not take care of that. So we are going to end up with a negative 4 to the 3rd power, m to the 2 times 3, which is 6th power, over t to the 3rd power. So this will become negative 4 to the 3rd power is 64. We have m to the 6, t to the 3, and that's all we can do. Okay, in this problem, we have an even exponent, so that's going to eliminate that negative in the parentheses. So we're just going to have s to the 3 times 4, which is the 12th power, over t to the 5 times 4, which is 20 power. And it will be positive because that's an even exponent. Okay, here we have the same base, so be careful not to multiply those. We're not going to multiply them because they're not coefficients. When the bases are the same, it remains the same in multiplication, but you simply add the exponents. So this is going to be 3 to the 11th power. I'll leave it in exponential form rather than evaluating what that crazy number is. Oh, I wrote down the problem wrong. Okay, be careful not to multiply the 3's together. Those are bases. They're not coefficients because they each have an exponent. So because they're the same, we keep them the same, and we simply add the exponents. So this becomes 3 to the negative 1. And to make that positive, we bring this down into the denominator. And so we end up with 1/3. Okay, here we have the bases. They're all the same, so it remains the same, and then we simply add the exponents. So this is going to become a to the negative 5, which will become 1 over a to the positive 5, and that's all you can do. Okay, in this problem, we'll distribute this, or just multiply that in. So this becomes k to the negative 6, that's 2 times negative 3, and we're multiplying by k to the 4, so that becomes k to the negative 6 plus 4, which is k to the negative 2, And then we'll make this a positive exponent by putting it on the other side of the fraction. So we have 1 over k squared, and that's the final answer. Okay, let's take care of the parentheses first. So we have the negative 4r to the negative 2, but this becomes r to the 2 times 4, which is 8. And then we're going to multiply the r's together by adding their exponents because it's the same base. So that becomes negative 2 plus 6 is negative 2 plus 8 is a positive 6. And that's all you can do. So oops, I didn't put the r down. This is r to the negative 2 plus 8, which is positive 6. And that's all you can do. Okay, let's distribute this 4, and we'll get 5 to the 4th power, a to the negative 4th power, times, and we'll bring this in, and we'll have a to the negative 6th power. Now I'm going to evaluate 5 to the 4th power. It's 5 times 5 times 5 times 5, which is 625. A to the negative 4 times a to the negative 6 is a to the negative 10. And finally, I'm going to make this a positive exponent by putting it on the other side of the fraction. So I'll end up with 625 over a to the positive 10. And that's all we can do. Okay, here I'm going to bring this in, and we'll have z to the positive 4, x to the negative 3. And then we'll make this a positive exponent by putting it on the other side of the fraction. So we'll end up with z to the 4 over x to the 3. And that's all we can do. Okay, in this problem, let's take care of the parentheses first. So this is going to become p to the negative 6 because negative 2 times 3. Down here we have 5p to the 4th. Now to make this a positive exponent, we bring it down to the bottom. So in the denominator, we now have 5p to the 4 times p to the 6, which is going to give us 5p to the 10th. Okay, let's get rid of this parentheses. So now we have 4a to the 5th times a to the negative 3. Down here, negative 2 times negative 2, we'll have a to the positive 4. So up on top, we have 4a to the 5 plus negative 3 is 2. On the bottom, we have a to the 4. And we can divide those a's, and we'll subtract the exponents. So we'll end up with a 4 over a to the 2nd, because 4 minus 2 is 2. Okay, let's bring this 2 in. So we'll have 2 to the 2nd, k to the 2nd, but we still have m to the negative 5. On the bottom, we'll bring this in, and we'll have k to the negative 3, m to the negative 3. Now, I'm going to move this up there, and this down here, and this up there. So I'll end up with 2 to the 2nd is 4. I have k squared and k to the 3rd, and m to the 3rd up top. And on the bottom, I have m to the 5th. Well, I have 4. I'm multiplying the k's together, so 2 plus 3 is 5. And then I'm subtracting 5 minus 3 is 2. So I have m to the 2 on the bottom. And that's all we can do. Okay, I'll bring the negative 1 in here. So this is going to be equal to 3 to the negative 1, k to the positive 2, over k to the negative 4. That's the first fraction, times 2 over k for the second fraction. And then I can do a couple of things. Maybe I can cancel one of those on each one. And then I'll bring this up to the top and this down to the bottom. So I'm going to end up with 2 from the top, k from the top, and now k to the 4 that came up from the bottom, over 3 from the top to the bottom. I'll multiply the k's up top, so I'll have 2k to the 1 plus 4, which is 5, over 3. All right, scientific notation. In scientific notation, you always write the number with a single decimal, a single digit to the left of the decimal. So the decimal started here because there wasn't one, so it must have started there. I had to move the decimal back twice to get it there. So it's going to be 5.3 times 10 to the 2 power because we moved it 2 times back. So 5.3 times 10 to the 2 is the answer. Okay, so again, we always start by writing the number down with a single digit to the left of a single non-zero digit to the left of the decimal. Then you have to decide how many times you had to move it to get it there. So we moved it 1 time, but this time we moved it to the right. So this is going to be a -1 power. Okay, again, we're going to start by writing down the number with a single non-zero digit to the left of the decimal. Then we're going to count off the number of times we had to move to get it there. 1, 2, 3, 4, 5, 6. So this is going to be times 10 to the, now it's a -6 because we took a small number and made it large, so we moved the decimal place to the right. So this would be the final answer in scientific notation. Okay, I'm going to write the number so that I have a single non-zero digit to the left of the decimal. And then I'm going to decide how many times I had to move the decimal to get there. 1, 2, 3, 4. So I have times 10 to the +4 value. One of the easiest things to remember is large numbers greater than, well, with the magnitude greater than 1 are represented with positive exponents. Small numbers with a magnitude less than 1 are represented with negative exponents, so small decimals. Okay, our job here is to change this from scientific notation into standard form. So I'm going to start by writing my number down. I know I have to move the decimal 4 times. The only question is which way. Well, this is a positive exponent, which means that I have to make this a large number. So I'm going to move it to the right to make it a large number, and I move it 4 times. And then I'm going to rewrite this so I don't have a number with a decimal place in 2 different places. And I'll put in a comma to make it easy to read, and it's 72,000. Okay, again, I'm going to start by writing down my number. I know I'm going to move the decimal 3 times. Because that's a negative exponent, I know I have to make this number small. So to do that, I have to move it to the left 3 times. And there's the decimal. Now I'm going to fill in my zeros. And again, I'm going to rewrite this number so that I don't have a weird number with decimals in 2 different places. Technically, you should always write a single leading 0 to the left of the decimal. And there's your answer. Okay, so again, I'm going to start by writing down my number. There's a decimal right here because it's not written. I know I'm going to move the decimal 4 times. It's a +4, so I have to make this a large number, so I'm going to move this to the right 4 times. And then I'm going to fill in my zeros. Again, I'm going to rewrite this so that I don't have a decimal place in 2 different places in my number, and I'll put in a comma to make it easy to read. Okay, again, I'm going to put this in standard form, I'm going to start by writing down my number. I know that I need to move the decimal 5 times. This is a negative exponent, so I have to make my number small. So that means I'm going to move the decimal to the left. So 1, 2, 3, 4, 5. I'm going to fill in my zeros. And then I'm going to rewrite this so I don't have a number with a decimal in 2 spots. And technically, you should always write a single leading 0 to the left of that decimal. But there's our number. Okay, I'm going to start by dividing 3 by 12. 3 divided by 12 is 1/4. 1/4 is 0.25. So I can do that math in my head. So now we're going to say times 10 to the -2 minus 3 is -5. But this number is not in scientific notation because we do not have a single non-zero digit to the left of the decimal. So now I have to move my decimal to the right to make this a 2.5 times 10 to the. Now, if I made this number bigger, I have to adjust by making this number smaller. And remember, a smaller number is more negative, not less negative. So I'm going to go from -5 to -6. And that's my final answer. Okay, I'm going to start by dividing 3 by 12 and I'll get 1/4, which is 0.25 as a decimal. Then I'm going to say that this is times 10 to the -2 minus 3. I'm subtracting when I divide, so that's a -5. But this is not scientific notation because I do not have a single non-digit 0 to the left of the decimal. So I'm going to have to move this over to the right to make this a 2.5 times 10 to the something. Now, I made this number larger by a power of 10. So to adjust, I need to make this number smaller by a power of 10. Making a -5 smaller brings it to -6. So that's a -6 there. This would be the answer in scientific notation, but it wanted the answer in standard form. So I'm going to write 2.5, and I'm going to move my decimal 6 times. Now it's a negative number, so I have to move it to the left. 1, 2, 3, 4, 5, 6. And I'm going to fill in the zeros. And I'm going to rewrite this so I don't have 2 decimals. So 1, 2, 3, 4, 5 zeros, then the 2, 5, and I put a leading 0 to the left of the decimal. Okay, if you didn't have a calculator to do this, it would be easiest to do this in scientific notation. So I'm going to put this in scientific notation. This is 5 times 10 to the -12. I'm going to make this in scientific-ish notation. This is going to be 16 times 10 to the 12. And on this, on the bottom, I'll make this 4 times 10 to the -1, 2, 3, 4. Okay. Now, up on top, I'll multiply the 5 and the 16 to get 80 times 10 to the -2 plus 2 is 0. On the bottom, I'll have 4 times 10 to the -4. Now when I divide this, 80 divided by 4 is 20 times 10 to the 0 minus -4 is a positive 4. That's 0 minus a negative, so that's a positive. Finally, this is not scientific notation because I have 2 places to the left of the decimal. So I have to move this decimal back 1, and effectively I'm making this smaller by a factor of 10. If I make that smaller, then I have to make this bigger by a factor of 10. So this becomes a 5. This would be the answer in scientific notation. But because I want this in standard form, I'm going to start with my 2, and I'm going to move the decimal 5 times. 1, 2, 3, 4, 5. I'm moving it to the right because that's a positive 5. I'll fill in my zeros, and I'm going to rewrite this without 2 decimals in there. So 1, 2, 3, 4, 5, and then I'm going to fill in a comma. So there's my final answer. And I realize that that's a lot of work that you could have done with just a calculator. But if you didn't have a calculator, this is a much easier problem to do in scientific notation.